it looks like we've got some people in here. I think we've got a critical mass, and you all know, hopefully, that today I am talking to Savin Goyal. He is one of the maintainers of Netflix's Metaflow. And the first thing that I'm going to ask him, Savin, when is Stranger Things 4 coming out? That's what I want to know.
Well, yeah, I mean, even I'm curious to know when is Stranger Things season 4 coming out.
I
I'll
knew
let
it.
you know as soon as I get to know.
I had a feeling you were going to play that off smooth. So that is not what we came here to talk about, is it? We came here to dive into Metaflow. This is a to be continued version 2 of this talk. If anyone was around on version 1, we had Ravi, your coworker, come on here and he gave us the breakdown of what Metaflow is. But I would love to know, before we start with any of that and get into Metaflow, you've had a pretty prolific career already. I can tell you're young still, so you've been able to accomplish a lot up until now. Can you just give us a bit of background on how you got to be where you are right now doing this with Netflix and working on Metaflow?
Yeah, great question. I think I was just incredibly lucky to be at the right point at the right time. And I think when I was graduating, there was definitely a desire to work in data systems. So early on in my career, I worked on big data systems, and then as the community evolved towards sort of like adopting machine learning more and more, it was sort of like a natural segue, and that's how I found myself working on machine learning systems. And Netflix, it happens to be a great place to do engineering. Uh, the company runs very lean and still has global impact. So yeah, it's nothing specific in the sense that yes, like I don't really have a specific action item or a plan that I can share, but I guess it was more about certain things that happened to me very naturally, very organically, and yeah.
Awesome. So, for those who missed the first installment of this chat, can you just give us a breakdown, real quick, of what Metaflow is and how it came about?
Sure. So Metaflow is Netflix's machine learning framework, and so it's used internally for all sorts of use cases that we have, ranging from analyzing our content slate, figuring out how to fight fraud on our service better, building intelligent infrastructure, and so on and so forth. So it was built to cater to a diverse set of use cases that we found ourselves getting more and more into. And also, the data scientists that we have internally at Netflix, employed on our roles, um, they're essentially experts in machine learning, experts in statistics, and other quantitative fields. And they essentially desired to have a machine learning framework that would essentially allow them to exercise their freedom of choice in tooling, what sort of algorithms they want to use, what sort of other monitoring tooling they want to use, how they want to actually go about building their machine learning models without sort of like the tool, the framework by itself imposing any sort of constraints. And that was kind of like the unique need that we had when we set about building Metaflow. And most of the design decisions that you see around Metaflow are mostly around fostering that sense of freedom. That yes, I'm not tied to a specific framework, or I'm not tied to doing machine learning or data science in a particular way. And but then at the same time, for any machine learning problem, there are certain concerns that cut across all the problems, right? Like you need to make sure that you have good lineage of all the work that you are doing, experiment tracking. You need to make sure that you are able to sort of like train and deploy your models at scale. And the definition of that scale can vary. Maybe you are processing a lot of data. Maybe you're not really processing a lot of data, but you're training a lot of models. Or maybe your model is pretty heavy and huge. And we wanted to make sure that our tooling could take care of all of those concerns, and the user there wouldn't be any sort of like necessary uh, expectation on their behalf to sort of like dive deep into systems engineering and figure out like, okay, how do I launch containers? How do I think about reproducibility? How do I sort of like move terabytes and petabytes of data across different systems? So we just like looked at all the different small little pain points that our data scientists were facing, and we decided to, okay, like let's just like uh, start building tools that can take care of each of those pain points one at a time. And if you do that for a sufficiently long duration, you end up with something that looks like a framework, and that's what we built.
That's awesome. So in the stack, where does Metaflow stand? Like, what do you feel like are other tools that are similar to what you're doing,
Mhm.
or what, and where, like, I'm just trying to get an idea of the workflow.
Mhm.
And I know that Netflix has quite a few tools
Mhm.
that the data scientists are using. So can you break down what that looks like and how, where it goes?
Sure. Yeah. So now when you look at say stack of machine learning, right? There are different components involved, and those components they sort of like stay true for any sort of machine learning problem. Like the very first stack is that of a data platform. So you need access to data. And for Netflix, our data exists in a variety of different formats. S3 is our data lake. So most of the metadata, most of the data sets are present in S3. And then at the same time, we are a video streaming company. So we have like petabytes of video data, the actual raw files. And given the increasing interest in computer vision and some of the benefits that it can have for us, we also do a lot of processing on those files as well. And those files live on S3 and are exposed using a variety of different mechanisms to our internal users. And now, once you sort of like go beyond the data stack, then the next thing that comes in is your compute layer. Now you need to process this data somehow, right? And again, there's a spectrum of compute layer for us internally. The most simple one is that of a laptop. And like if you can just do your work on a laptop, if everything fits on your laptop, that just affords a very high degree of flexibility. And a lot of problems that we solve internally, things can just fit on a laptop, and we want to make sure that we are providing some sort of support for that. Then you have cloud workstations. So say an EC2 instance or Docker container running on one of these EC2 instances where people can log in and they can do their work. And usually these will provide them a lot many more resources than what general purpose laptop or Mac can provide you. And then at the same time, there are certain bespoke needs that people have that, hey, I need to run some compute that might need, say, a terabyte of RAM. And at that point in time, you can very easily farm out that compute to EC2 instances, which provide very exotic combinations of resources these days. And those combinations, they are only growing day by day. And for a lot of organizations, this container orchestration system essentially looks like sorry, it essentially looks like some sort of like container orchestration system, predominantly say Kubernetes or like AWS Batch. And internally at Netflix, our container orchestration system is called Titus. So it's an open source project. It predates Kubernetes and provides like very similar guarantees as well. Then now, if you go a level beyond this, right, now these compute instances, they are running containers. So then you need to have some infrastructure to either build and bake these Docker containers and deploy to these instances. And that's, again, like some sort of infrastructure that needs to exist. We have some homegrown CI/CD around Docker images. There's a lot of tooling that exists outside in the world as well. And then also you need some sort of orchestration infrastructure as well. So these machine learning models, like many times people want to run these at particular cadence. So at Netflix, we are logging a lot of data. So anytime we have, say, a fresh data set, we might want to re-trigger model training, or maybe we might want to re-trigger model training every week, every day, every few hours. So you need to have some sort of workflow scheduler that can take care of that. Airflow is an open source alternative. The clouds, they provide some tools as well. Internally, as it happens with many other big companies, we have like, tens of internal workflow orchestrators that people have built for specific use cases, and you have to work with like most of those. And then if you then start to sort of like go beyond this, then you sort of like get into the realm of MLOps, which is around like, okay, now all the layers of stack that I spoke about, they don't necessarily have anything to do with machine learning. But now, if you're say running a workload, which is a machine learning workload, then there are like certain extra things that you need to do, right? Like repeatability becomes a big concern. That whatever I have, whatever workload I'm executing at any point of time in the future, I should be guaranteed that I can execute the same workload and notionally get similar results, right? Like that would be like something at minimum, right? And then given that it's a very iterative process as well, like building machine learning models, you need like experimentation as a first class citizen. And also performance becomes really, really important. For a lot of people, like performance usually means like machine performance, but now as it happens, machines are actually rather cheaper than data scientists. So you have to focus on equal measures on how productive your data scientists are being. If let's say,
That's
a
a
data
great
scientist
point.
is spending more than half a day just like building and making a Docker image and like trying to sort of like fight dependencies, that's lost productivity for a business. So that's the stack, and I'm pretty sure like for a lot of people who are attending this call, in their organizations as well, the stack would look very much similar in some sense. But now, what's sort of like tricky is how do you sort of like move between these layers of the stack, right? So now let's say if I need to train a TensorFlow model and say I need to train hundreds of TensorFlow models in parallel, how do I go about launching those 100 instances in parallel, making that Docker image, moving my data from my data warehouse to
Yes.
those Docker instances, training that model, getting that result back, still maintaining some sort of like strict lineage and experiment tracking. And that becomes harder. There are, of course, best practices. And, given that members of my team and myself, we have worked in this area for like years and years, we have those practices that we have sort of like come across. But then ideally to provide better leverage, it's nice if we can bake all of those best practices into a software system. And that's what at the end of the day Metaflow is.
So many
That
good
was a
things you said
long-winded
there.
answer.
Yeah, so much. I mean, and so what I kind of got from that, you went very vertically on the stack, and just a lot of people in here probably already knew that Netflix recreated its own Kubernetes, but that's news to me, and that's pretty amazing. It doesn't surprise me, but it's definitely interesting to hear about. I I have heard about Runway. That's
Mhm.
another project. Can you break down like where Metaflow starts and Runway,
Mhm.
and what those two, like why they're separate and
Mhm.
what they do?
Sure. Yeah. So a bit of a historical context here. So Netflix has had like really big investments in the recommendations infrastructure space. And if you look at recommendation systems, like 10 years ago, 15 years ago, most people who were doing machine learning, they were more or less in the JVM Scala stack. So our recommendations infrastructure stack is pretty much in the JVM Scala wheelhouse. And now we are sort of like in the process of sort of like figuring out like, okay, what does the future entail? And what are the pieces that we can continue to use from that part of the universe, and what are the latest and greatest in the Python and R ecosystem that can again sort of like get us more leverage. And in that scheme, Runway is essentially for us a model management system where at the end of the day, you have users who are building these really complicated recommendation models. And now these recommendation models, they are serving inferences to all the members who log into Netflix. And we need a mechanism to track which models are actually being used, how they are performing. We also bundle in with like some of the monitoring solutions that we have internally. And that's the kind of tooling that Runway provides, which is more focused on just the model management lifecycle for member-facing or like Netflix subscriber-facing inferencing. While the use cases that Metaflow is currently solving at the moment are more around training models in Python and R, as well as function as a service platform for hosting some of these models for internal use cases.
Oh, okay, I see. So we've got a question in the chat from Ron. Thanks for asking this, Ron. He's wondering what tools or storage does Netflix use for DataOps, i.e. the front-end management of data sets, and how does that integrate with Metaflow? So Ron, I think you may have misheard us. It's Metaflow, not MLflow that we're talking about.
Sure. Yeah, that's a great question. Now, my team, we stand on the shoulder of the giants. So Netflix has a very advanced data platform, and there are like numerous presentations on that on the internet. So I would highly recommend checking those out. But I'll sort of like give you a brief TLDR on like what we have available. So as I said, all of our data it's stored in S3, and we were sort of like one of the very first companies to use S3 as our data lake to decouple storage from compute. If you look at, say, like some of the big data systems that were being built 10 years ago, like the Hadoop ecosystem that would couple your storage with compute. And at that point in time, we decided that, for us, that decoupling is rather important, and we would essentially prefer to pay the cost of moving data over the network just so that we can have this isolation, and then we can have a variety of different query engines to run on top of S3. So this data, you can access this data through, Presto, Spark. So we have all of those query engines available internally to our end users. And also very specifically for data access for machine learning, usually what ends up happening is that the data scientists, they are usually interested in just like fetching one single partition or a bunch of partitions from a table that's available in the data warehouse. And what we have seen in practice is that going through a query engine for those sort of requests is usually not really that efficient because you're overloading the query engine. And then, if anybody else is running a very heavy query on the query engine, then it will also penalize the amount of time it takes you to get your data back. So we have invested in tooling within our team so that you can directly go to our data warehouse and we can like bypass short circuit these query engines and get you access to this data as quickly as possible to the tune of 2 to 4 Gbps depending on the instance type that you're using. And so we have made like big investments around data access. And then, of course, there are other concerns that cut across machine learning, which is like, how are you cataloging your data systems? How do users even figure out what data sets actually exist? How are you sort of like managing the governance policies, and how are you taking care of TTLs and all of that? And so our data platform team, it provides us all of that tooling, and we just piggyback on that.
Awesome. And I know I was watching a video with you, I think it was Op ML or something like that, some festival or conference.
Yeah.
Hard to have festivals these days, but in that talk, you mentioned how when we think about Netflix and machine learning, we think about the recommender systems. But now it's kind of bloated and grown into such a big part of Netflix just business model. Can you explain the other areas that you're using machine learning?
Yeah, I mean, as you can imagine, right? Like Netflix, it's a major company in the entertainment business, and in every company's life cycle, you sort of like hit a point where to sort of like gain any further progress, you have to sort of like start investing in data science because everything is running at such a high scale. Right, and like just to articulate like some of the problems that we run into where we use data science is whenever we have to roll out, say, any changes to the services that power your experience. Now, these changes, we have to be very mindful, right, that we are not in any way hampering your viewing experience. So we'll roll out a small canary, we'll observe how it's performing, and then if it's performing as per expectation, then we'll roll it out to like bigger audience, right? And this needs to be done with care. But then, okay, how do you figure out, given that if Netflix is available on hundreds of different devices and people are using Netflix with like different kind of internet connections and all, any change that gets rolled out, how do people sort of like build confidence on those changes? So we observe, like some of the quality metrics, the quality of streaming that you're getting, and then we sort of like roll it back, and there's like some analysis that's done to sort of like qualify a change set that, okay, like is it green, and can we sort of like roll it out to many more people or not? And some of this work is actually open source as well. So our canary analysis tool, it's called Kayenta. And also another Netflix open source tool is Spinnaker. That's our CI/CD tool. So it works hand in hand with that, and that's like one of the areas where we have significant investments in machine learning. Then we are processing like a lot of payments, so we need to be very crafty about like just like detecting fraud that's happening on our platform. So we need to invest in those areas. Um, Content analysis is again one area that we try to sort of like uh, use data science to look at, like what's working for us, what's not. Yeah, I mean, as you can imagine, right? Like just think of a big company that Netflix is, and at a sufficient scale, each of the problems that could be just solved by heuristics, you sort of like start to reach the limits of those heuristics, and that's when you have to introduce machine learning. And that was indeed like sort of like the motivating factor for us building Metaflow, because now each of these different problems, they require different solutions, they require different tooling. The data scientists who are working on each of these problems, they have very different skill sets as well, very different areas that they specialize in. And we essentially wanted to sort of like build something that could just like take care of their daily pains. And yeah, that was the entire exercise.
And that leads perfectly into the next question that I was going to ask you about. Like, what do you feel the hardest part of building and operating machine learning workflows is?
Honestly, everything is hard. And at the same time, everything should be rather easy and straightforward. So unfortunately, I don't really have like one single thing that I can talk about that, hey, like this is the thing that is the hardest. Like I can give you a laundry list of maybe like tens and like hundreds of things that I find are like equally important, because it's like if you have to build a well thought out system that works really well in practice, then you have to focus on all the components that go in. If you miss out on even one, then that will just like lead to more grief down the line. So as I said before, right, like one of the most basic things for any sort of like machine learning project is around data, right? How do you make sure that your data is of appropriate quality, and not just like of appropriate quality when you looked at it for the first time, but as you are getting more and more data, the quality bar is maintained. And that's a big problem that a lot of very smart people are trying to solve, and people are making good progress on that front. Then how do you get access to that data? So like most training algorithms, they take input data as data frames, versus the data that's persisted in data stores is usually often in the form of tables. So there's this significant amount of work being done that, okay, how do we sort of like get access to this data as efficiently as possible in the correct format, so that you're not spending, say, minutes or hours just like moving data around. Then cost becomes again one big concern, that yes, of course, like a lot of these things, if you don't care about the cost, then you can just like throw more and more resources. But then for a lot of organizations, it just isn't prudent. Like we live in a real world, so everything has a particular cost. And the cost is not just in terms of like like what your AWS bill is going to be, but also what is your total ownership cost of your machine learning systems, how much data scientists cost, and like what would be the operational burden going forward, how do we sort of like minimize that to the best of our abilities. Then reproducibility is something that's sort of like very near and dear to my heart. And the academic definition of reproducibility is that, yes, we have a data set and we have the code, and that should usually be good for reproducibility. But in practice, that's never really the case. So yes, of course, you need the data set, you need the code, but then at the same time, the world is moving, right? Like say, if you install a specific version of PyTorch today, it will pull in some underlying dependencies. If you install the same version of PyTorch tomorrow, it will pull in a different set of dependencies, and your behavior of your trainer can sort of like change. And then at the same time, like one thing that's incredibly hard to do today is collaboration. So it's really tricky for data scientists to meaningfully collaborate with one another, and that's where sort of like repeatability becomes a big concern, right? Like if let's say you're working on a model, but I can't really take your code and run it reliably on my own laptop or whatever system I have available, then I can't even think about building on top of it. And so I think the need of the hour of like the entire MLOps community is to just like, think about how can we sort of like move from a world where, say, you have like 5 data scientists on a team, each of those working on an individual problem by themselves, to say 5 data scientists meaningfully collaborating on a single project. Because I think very soon we are going to sort of like also hit the bounds of like how much context one person can keep in their head and deliver on a project. So yeah, that's another component.
So many good points there with that. I mean, you made this point earlier too, and the cost, like optimizing not only spend or optimizing not only the data science workflow, but optimizing what the data scientist is doing is such a great point. And yeah, along with that, I mean, this reproducibility, I know it's part of like the 3 pillars that you all are using, and we'll get into that in a second, but it's such a great point that you were talking about this, because I remember about a year ago, I was talking to a friend and he was saying how he had to work on a colleague's, I can't remember, it was like he had to figure out the model that a colleague had made. And he said for like the first week and a half, he was just figuring out what was going on. And it was like he was going around this labyrinth and trying to pick up these breadcrumbs, right? And trying to see, okay, what's happening here? And I spoke about this just last week with Neil Lathia, who's the head of ML at Monzo Bank. And he was saying how difficult this problem is because it's very much in our heads, right? Like machine learning, and especially when it's exploratory, where maybe we're trying to research, and so we know what's going on very clearly. But when we try to go into what someone else is doing and we try to pick up the whatever they were working on, then it gets very difficult. So I love that you're trying to attack that problem, and maybe we can just talk about these 3 pillars and why you chose these 3 pillars. I think it's pretty clear that the reproducibility one is huge. It's really important. And then there's scalability, and then forgive me because I forgot the third one.
Yeah. I mean, I guess this was like a presentation that I gave a long while back where we had like reproducibility, scalability, and usability. And for that presentation, we essentially wanted to focus on like 3 ideas. So we like, yes, like these 3 ideas are kind of like really relevant for us in practice. And that's why we sort of like mentioned that. But yes, of course, there are like a lot of other sort of like dimensions to machine learning systems as well that are equally important. Now, on the reproducibility side of things, I mean, the reality is that the problem is difficult. If it wasn't, then it would have already been solved. And I mean, I don't claim that, like we have solved the problem. Ultimately, at the end of the day, there's no like one single definition of reproducibility as well. Like, if you are trying to make things reproducible, then theoretically, like you need to have like an audit log of everything that has happened, and this audit log by itself, you should be able to sort of like walk back in time and replay that audit log So it's not just like I could capture like what all changes happened, but I should be able to roll back to a particular state and be able to meaningfully execute on that. And the components that I spoke about, right? Like data happens to be one. So you need to have a data platform story that your data platform underlying data assets actually allow you to do that rollback. Many times people don't have that capability. User code is another one. And, like you have like version control, you can just like copy code for every execution, and that sort of like gives you some rollback guarantees. Then you have like dependencies, like library dependencies and all, and you can also snapshot those and also, so there are like solutions around that as well. Then the fourth one is that your actual runtime, your infrastructure is also rapidly evolving. So you need to make sure that there is some way to roll back that as well. And then ML models by themselves, they have like sufficient degree of entropy, sufficient degree of randomness. So you need to have a story around that, which is like very, very tricky. And now all of these, like managing all of these entropies and rollbacks and audits, these all incur some cost. And many times on the basis of like whatever problem you are in, it might be okay to forego some notions of reproducibility because frankly you just don't care about that as much, right? And so it's really important to sort of like keep that viewpoint in mind, and then sort of like design systems that, yes, at the end of the day, it's all about trade-offs, right? Like there's no like one true system that just like promises you the holy grail of reproducibility. It's all about like, okay, like what are the things that you care about and what are the things that you're okay sort of like not really worrying about as much. And so for us, when we looked internally, like if you're running any sort of machine learning workload in production, even if for a moment we don't think about the collaboration and the shareability aspect, one thing that's really important is that how do you recover from failures, right? Say you have a training workflow and that training workflow failed for whatever reason in production, right? Now, as an end user, I want to be able to replicate that exact same error. I want to be able to run that pipeline and recreate that failure so that then I can figure out how to fix that, right? Otherwise, then I'm shooting arrows in the dark, hoping that something will stick. And that again, like leads to a lot of heartburn and leads to a lot of loss of productivity cycles because you don't really know how to fix the problem if you can't really even reproduce it in the first sense.
Totally.
So for us, this notion of repeatability, this notion of reproducibility was more from the debuggability angle, right? Anything that you're building, they need to be debuggable, right? Like things are going to break, things are going to fail, your data distributions are going to change. Some of the assumptions that you had baked in might not hold true, say, 3 months from now, 6 months from now. And at that point in time, you need to be able to go back in time, look at like, okay, why were certain things working? Why are certain things not working? What's the delta? And then sort of like work your way around that. And so that was really important. Now, on the scalability side of things, um, we also do understand that, like for us, when we started building Metaflow, the notion of scale was that of like diverse set of problems. But then when we are looking at the diverse set of problems, like one thing to note is that the iteration cycle of a data scientist, like they usually start off on a small data set, right? Like say something that fits on their laptop or something that fits on their cloud workstation. But then very soon they'll be like, okay, like this thing works. Now I want to train my model on the entirety of the data set. But now uh, this data does not fit in the instance that I have. What do I do next, right? And we want to make sure that like there are many different solutions that you can do at that point in time. Like, but the simplest one that also has the lowest amount of operational overhead is if somehow we can sort of like give you access to a much bigger instance, so that you can just like whatever code you had, you just execute that code on a much bigger instance without making any changes to your code, right? Like that would be like far more simpler and straightforward. So we wanted to make sure that we were providing those primitives so that if let's say I'm training a model, I run into an out of memory exception, and then I realize that like I only have 16 gigs of RAM on my laptop, but what I need is like at least 100 gigs of RAM. Then I can just like change like one annotation, and then the code automatically runs on an instance which has 100 gigs of RAM, and then all the results are piped back to me. While I don't have to think about that. This instance was actually in the cloud, and if you have an instance in the cloud, you need to first create a Docker container. You need to put your code in. You need to get the data somewhere. Then you need to get the results back. as a data scientist, I don't really want to know all of that. I just want the capability to just, here is my code, the system should know everything else, and the compute should just execute and give me back the results.
Uh-huh.
And then, like if you sort of like stretch this idea further, then okay, so like can I run multiple copies of my code with different parameters on multiple different instances? And that also again, like gets you a little bit farther ahead. And of course, there comes a point where, like your model size becomes big, your data size becomes so big that you have to go through like some distributed model training approach. But there's sort of like this entire world and of like just like scaling your instance vertically, or then just like scaling instances horizontally, and just like doing some rudimentary sharding of data that gets you much further along. And that's another recommendation that we have for our users internally, that yes, just like think about like some of these basic primitives before thinking about anything super complex. But then yes, if they can't really do without distributed model training, then yes, of course, we'll go in and we'll support that as well.
So I'm
And
wondering, sorry to cut you off, just
yeah.
along that point, and I see there's a question from Kenny. I'll get to that in just a second, Kenny. But I'm wondering, like, you're giving people basically so much power, right?
Mhm.
That they could do a lot of harm with it too, because they may just be like, well, I have unlimited resources. Let me just train this insane thing, or let me just have these instances that are insanely large. How do you
Mhm.
keep them from
Mhm.
going overboard?
Sure. Yeah, that's an excellent question, and something that we have given internally a lot of thought about. So when you look at like these container orchestration systems, right, and that's where like beauty of like some of these systems, like Titus that we have built internally, and AWS Batch with which we have an integration in the open source, come in handy, where they have this notion of queuing and priorities. So you can have like certain queues which only have access to a certain fixed amount of compute. And that means that no matter how many jobs you launch, it can at any point in time only support a set number of vCPUs or GPUs, and all the other jobs, they'll just like wait in the queue. And if you are being creative with these queues and the priorities amongst your queues, then you can very easily provide flexibility to your data scientists, where if they just want to sort of like do some sort of exploration, then they have access to a limited number of instances in their compute environment. And once everything is approved and okay for production, then they should be able to move their compute into a queue, which has access to far greater resources.
Okay, that makes sense. So Kenny's asking, can you explain this pillar of usability? He's
Yes.
curious as to what the usability pain points you've had to
Mhm.
resolve were.
Yes. Yes. So for us, Metaflow was inherently a very big exercise in usability. So like my fundamental belief is that tools should work for people and people should not work for tools. And so for us, it was rather important that we don't place an expectation on our data scientists to be systems engineers. And also, like Metaflow, it's a Python library, it's not a DSL. And that was a very conscious choice, because as soon as you introduce a DSL, then people have to sort of like flip through manuals and understand like, okay, like how to sort of like work through that DSL. And but if you're just like using a programming language that you're already used to, and the reason why we went with Python and R was because these people, they are working in these languages day in and day out. So that's what like makes it rather simple and straightforward for them. And then at the end of the day, as I said at the beginning of this conversation as well, um, there's like the machine time, and then there's people time, right? And we ideally, I wouldn't want my data scientists to like spend a lot of time making Docker containers, flipping through the manuals for Titus and Kubernetes and AWS Batch, trying to think about like, hey, what does this Kubernetes error code mean? Also, if you're running anything on the cloud, right, like instances fail all the time. There are like a lot of errors that happen. So you need to have a good amount of like, resiliency baked into the system. And that resiliency should also be exposed to the user in a very easy to consume manner. And that's again something that aids in usability at the end of the day. Yeah, I mean, if you look at, say, like everything that I spoke about, like, walking between like different layers of the stack, there are like a whole bunch of things that people need to do. And our goal was to abstract that away, but even then, not really hide that, all of these activities were happening behind the scenes, because when failures happen, they should be able to go in and debug. Like one example here would be that every single time you execute your code, we actually snapshot the code and we store that in perpetuity. And that's sort of like the executable runtime, which we try to make as reproducible as possible. And now, if a user had to do it by themselves, then they would sort of like find themselves in some sort of like version ops world or GitOps world, and that hampers their usability, right? Then what it means is that every single time I execute my code, I need to take a few more actions to make sure that I'm logging what the behavior of my code is, what my actual Git hash was, and so on and so forth. And we would want to take care of that out of the box for them. There should not be any extra step that they should be taking. So for us, it's more of an exercise in design that can we sort of like remove as many actions that a user needs to take for any of these operational concerns, and that's sort of like the usability angle.
Sweet. So I don't know if you can answer this one, but role-based access control has been something that has been coming up a lot
Yep.
recently.
Yep.
And I'm wondering how you are doing that, especially when it comes to data, because data is so sensitive, right? And so
Yep.
how does, I don't know if Metaflow does anything specific for that, or if just inside of Netflix you're doing it some way, but can you speak to that at all?
Yeah, definitely. Like as you can imagine, even inside Netflix, we do have some data sets that are like far more kosher, and need to have like a higher degree of security and access control compared to some other data sets. So we do have systems internally that will authenticate certain workflows and only allow access to certain individuals. And now, as it happens with Metaflow, right? Like so, we don't want to bake in any of these controls within Metaflow, but we want to make sure that Metaflow obeys to any of these constraints that are placed. So, for example, for our integration with AWS and open source, we obey all the IAM restrictions that exist, right? So, uh, like another example is that right now you can go to metaflow.org/sandbox, and we'll essentially give you a cloud instance which has like certain number of vCPUs, has S3 buckets, has like step functions and everything, so that you can very easily try out Metaflow on the cloud and see, like this thing actually works. And behind the scenes, we have to make sure that there's like strict isolation, that people are not able to read anybody else's data, and the data is cleaned out as soon as their sandbox expires. And all of that machinery essentially happens via IAM policies, IAM rules. There's like nothing specific that we have baked in Metaflow. So if let's say there are many organizations who have a specific posture towards security access, and we want to make sure that they can just pip install Metaflow and it just works out of the box for them without us needing to do any sort of like customization. And then that gives all of these organizations much greater degree of flexibility as well as control over how they want to manage their data sources, who can launch a compute instance.
So I'm getting a question in the chat here, and I believe I know the answer to it. But is Metaflow based on Kubernetes? It is not, right? Or is it?
So it's a good question. So Titus internally has moved on top of Kubernetes, and we have an integration with Titus. So as far as like a compute platform is concerned, so there is a Kubernetes integration, and Metaflow by itself, it follows a plugin based architecture. So for us, it's more about like, okay, this is a unit of compute, and now we need to execute that unit of compute somewhere. It could be your laptop, it could be a cloud instance, and there are sort of like PRs open, and it's also an active area of work for us in the open source community as well, to have like more Kubernetes integrations. So that's where we are at right now. But the official open source integration that we have right now is with AWS Batch.
So let's talk a little bit about the open source, because I mean, it's one thing to be doing this for Netflix specifically, but then you go and you open source it, and I'm sure that opens up a whole new can of worms.
Mhm.
What have you seen since you open sourced it? What are some learnings that came across that you didn't have when you were
Mhm.
working at Netflix?
Mhm. So now one thing about Netflix is that we have this culture of freedom and responsibility, which means that our customer teams, our data science teams, they have the freedom to utilize whatever tooling works best for them, which includes any open source alternatives or any other commercial solutions. So even when we were building Metaflow at that point in time, we had to make sure that yes, like we would only build something if we felt that there were certain tools that were lacking in the ecosystem at that point in time. So like 3 years ago, when we started building Metaflow, the MLOps world looked very different. But then at the same time, we wanted to make sure that yes, of course, we don't want to build something that already exists. If something already exists, we would much rather adopt that and build different things. Case in point being our use of the AWS cloud, right? Netflix would have gone and built their own data centers. Amazon is always going to excel at that. So we're like, yes, we'll just like leverage that and build tooling on top of that. So in that sense, when we open source Metaflow, we had somewhat of a fair idea of like what other tooling existed. And that was sort of like the big rationale around open sourcing Metaflow, where we felt that, yes, there is a gap in terms of the tooling that exists, and we can sort of like make a meaningful contribution to the community. And ever since open source, like we have spoken to a lot of companies, a lot of individuals who are using Metaflow, who are keen to adopt Metaflow as well. And that has also honed our thinking around how the community is evolving, how people are sort of like looking at things, and has allowed us to sort of like either validate some of our hypotheses that we held
Mm.
that yes, like these are some of the areas that hold much more stronger promise for us, as well as some of the things that we were thinking about that okay, maybe this might be useful, and turns out that maybe people are not really too keen on those things.
And
And
so,
data access happens to be like one of those areas where it indeed is a real pain point for a lot of people. Like what does the data ecosystem look like? How do I get access to data, and like what are some of the good patterns around just like arranging data in my data
yeah,
warehouse?
yeah, I remember talking to um, a guy almost a year ago, and he was telling me how, so he worked in health tech, and it was a global company, and they were only allowed to use the data that came from Canada in Canada. That
Mm-hmm.
data could never leave Canada. So his problem in his head was, how can I make sure that only people in Canada have access to that data? But
Mm-hmm.
then they also have access to all the other data, right? So there's a lot of things that are happening right now. And I know that's why this keeps coming back up, is like, how can we access? What are the rules? What are the best practices around this access?
Yep.
And that, along with security, is starting to crop up more and more. And I'm wondering, I guess we've got just a little bit of time left. This may or may not be our last question, but I'm wondering what kind of trends you have been seeing, and what are these things that you thought would be interesting, or what people are asking for? Where do you feel like the market is going? That kind of big question that you can answer in 2 minutes or in 2 hours.
Yeah, no, I mean this is a very loaded question, right? Like, yeah, I mean we are definitely seeing like a lot of activity happening around like all layers of the stack. I mean, just recently, Tecton raised a big round. A lot of activities are happening on the feature store side of things as well. And then model inferencing is becoming a big hot topic as well. And on the topic of inferencing, like there's like a strong push around what does like microservice based inferencing look like. But ultimately, at the end of the day, the problem is more around like, okay, you have these models, and now these models need to interact with the real world. And what are those integration points like? And those integration points could be a microservice, they could be some sort of like in-process communication, some sidecar, could be some batch scoring. Similarly with feature stores as well, right? Like feature stores are kind of like, what databases are to software engineering. And ultimately, at the end of the day, you don't have like one single database. You have like a lot of different databases suited for like different applications. So I think now the industry is evolving towards the point where, like they're moving from like one definition, like, hey, we have a feature store, to like, hey, this is a feature store suited for this particular use case, and these are the constraints and these are the trade-offs that we are making. So yeah, I mean, we're sort of like going through the normal cycle of maturity in this ecosystem, where early on people were like, yes, we have these problems, let's build something. People build something, and they were like, yeah, maybe like some of the things that we build might not really have hit the target. But then as you learn more, you sort of like hone your understanding better
Yeah.
about the problem. And I think that's the cycle that we are in.
Hmm. Great answer. So I guess I can sneak one more in before
Sure.
we finish. And I'm wondering how you've seen companies on when we're talking about the open source market, how have you been seeing companies using this? I instantly think because reproducibility is such a big deal with
Mhm.
Metaflow, I would imagine that it is very well liked by the fintech or
Mhm.
banks because
Yep.
for them it's huge. And
Yep.
when you said, "Oh yeah, reproducibility for us was more about trying to go through and do these bug bashes."
Mhm.
I didn't even think about that. I was more thinking about, okay, when you're having to deal with laws and regulations, you need
Mhm.
reproducibility, right? So,
Mhm.
what are some of the companies that you've been seeing really interested in Metaflow? And then also, how have you been seeing them combined it with other
Mhm.
tools that are out
Sure.
there?
Sure. Yeah. Great question. So our essentially, like because our focus has been to reduce the accidental complexity in machine learning systems as much as possible, we've seen a significant uptake from organizations who have major investments in machine learning, but who don't want to sort of like, spin up yet another team to manage a machine learning platform per se. And they already have some deployment on AWS, some cloud presence, and they're like, yes, like this tool sort of like helps us get more productive without actually having some person who's sort of like carrying pager duty or anything of that sort. So like small companies, startups, there has been good adoption so far. Um, and then on the point of like verticals, yes, I've come across like a lot of banks, a lot of healthcare companies use Metaflow, a bunch of hedge funds, automotive majors, retail firms. So there has been adoption across the band. Now, the problem with an open source project is that you don't necessarily get to know who all are using Metaflow unless somebody reaches out to us and they're like, hey, here's some feedback, or hey, here's something that's broken and you need to fix that. So my understanding of like all the adopters of Metaflow is unfortunately kind of like broken. So yeah, that's there. And then I guess the next question was that how do we play with other open source tooling? Now, so we are an open protocol in the sense that within Metaflow you're just like running arbitrary Python code or arbitrary R code, which means that you can import anything and everything that you want. So I know that a lot of people like MLflow's model tracking or like metric tracking API. And we do have people who just use MLflow within Metaflow steps. And then that gives them all the benefits of Metaflow. And then they also have the benefit of going into the MLflow UI and looking
Mm,
at like all the metrics that they were logging and tracking. And we have people, who use Metaflow for training their models. And then once their models have been trained, then they'll host those as a Cortex model.
uh-huh.
So that's something we have heard. Yeah, I mean, plenty of these sort of instances have come across so far.
Yeah, I imagine there's a ton of use cases that we do not have time to get into today. So, Savin, thank you so much for talking to us and giving us this breakdown on Metaflow. I know it is for me, I love the project. I love what you're doing for the exact reason that you said. Like, you are basically at Netflix and you have to, because of the culture of Netflix, you are allowing people to say, yeah, we want to use this, or no, we don't, right? So you have to bring the A game when you're creating this, and you have to make sure that it is able to plug and play with a lot of different things. And
Mhm.
so I really appreciate you doing this deep dive with us. And I want to say thanks, even though you didn't tell me when Stranger Things is coming out. If they're even recording, nobody's on anymore, so it's all good if you can tell me if they're even recording season 4 yet or what is going on. All right, I won't press you.
Honestly, I have no knowledge on that.
They don't tell you, huh? So thanks everybody for sticking around. If you're still with us, and join us in the MLOps community Slack. If you are not there already, I'm throwing the link to that in the chat again for the last little piece. And other than that, yeah, Savin's in there. And so if you want to continue this conversation with him, he is there. I'm sure he would not mind if you reach out to him. And the last thing, I guess, would be if they don't want to come into the community chat, you're also on LinkedIn. You can find him there. Are you on Twitter? You are on Twitter, I believe. So he's all over the place. You can find him wherever the internet is found. All right, Savin, I really appreciate it, man.
Yep. Thanks for having me.
Take care, everybody.